All right, sometimes when we do domain and range, sometimes we smoosh, sometimes we highlight. It really just depends on what we're looking at. So in this case, I'm going to smoosh and highlight because I can highlight to help me find the boundary of my x, and I can smoosh to help me figure out where my y is. Okay, so first of all, I'm going to highlight to kind of block this part off. Okay, so I can see, and then just because, why not? I'm going to smoosh this up. Okay, so I see that all of my x values here are greater than -2. Since it's a dot and not a circle, they're also equal to -2. So that is my domain. X is greater than -2. All right, now, when I look at my y values, I'm just going to erase this because I don't want it to confuse things. When I look at my y values, I only see one y value right here because this is a line moving along there. This is the only y value I have. Y equals -1. So this is my domain, and that's my range. Okay? Now, smooshing is especially useful when I'm looking at dots. Okay? Because when I'm looking at dots and I smoosh, let me go grab a marker to make this easier to see. When I'm looking at dots and I smoosh, I just smoosh them down onto the axis, onto the x or y axis, and then I use that to help me figure out exactly which values I've got. Okay, so I'm going to smoosh these onto the x-axis so I can see what those values are. Well, when I look at that, my domain is going to be a list because there's 1, 2, 3, 4, 5, 6 dots. If I'm looking at dots, it's discrete. Discrete means I have a list. Well, those values are -3, -2, -1, 0, 1, 2. That's, and see how like that is supposed to be a fancy bracket, by the way. They start to get a little crazy. Clearly I'm fancy bracket challenged, okay? Now when I look at the y's, I'm going to do the same thing. I'm going to smoosh those dots. I'm going to make them a little bigger so that it's a little easier to see which ones are the x's and which ones are the y's, okay? Well, now when I look at my y's, which are my range, see, look, that one looks horrible. It looks like some kind of sad little e. Anyway, I have -1, 0, 1, 2, 3, 4. Okay, that's my domain and range. Since it's a list, since it's a bunch of dots, I do discrete. Discrete means a list. This one was a line. Since it's a line connected, it's continuous, so it's going to be an inequality or an equation. Okay. Now this one, let's take a look at this one. This one is never a better case for smooshing have I seen, okay? Because this one, I'm not quite sure what's going on. So if I look at I've got an arrow here, so I'm going to smoosh this onto here, and I've got an arrow here, and it's connected all the way through. That tells me I have continuous data, which means I'm going to have an inequality. Well, in this case, though, I got arrows going in every direction, which tells me this line goes on forever, which means that my domain is all real numbers. And again, the fancy R is all real numbers. Okay? Now, if I do the same thing and I smoosh up onto the Y to find my range, I kind of have the same thing working here, look. Because I just have a line going in both directions. That means my range is also fancy R, all real numbers. Okay? Let's look at this one here. Now, this one has boundaries. So if you look, right here, it stops. Right there, it stops. And over here and over here. So this is a perfect candidate for using my highlighter to box it in. Anytime I have something that's boxed in every direction. Now notice, I didn't color up here. I went to the lowest point and I colored. This number right here isn't going to have anything to do with anything because it's not the lowest Y value I see. Over here, that's the highest X value. This is the highest Y value. And right over here is my highest X value. Lowest X value, I'm sorry, it just got weird. Okay, so now, when I look at this, I have X values going from here to here. Well, this is 1, 2, 3, 4, 5, 6, 7, -7, all the way to 1, 2, 3, 4, 5, 6, +6. Okay, my Y values go from 2, 3, 4, -5, all the way up to +4. Now notice, even though -5 is not, it's the lowest point I've got, so it's what I'm using. I'm not going from the start of the line to the finish of the line. I'm going from the highest x value, the lowest x value to the highest, the lowest y value to the highest. Since this is connected all the way through, I'm making an inequality, okay? And I'm using or equal to because these are dots. If one of these was a circle, I wouldn't do or equal to, okay? So for this one, my lowest x value is -7. My highest x value is 6. So that means this is my domain, okay? For my range, I'm going to do the same thing. I'm going to put y in the middle, though, because range is always my output values, my y values. My lowest y value is -5. My highest value is +4. Now, the question is, do I always use less than signs? Yes, because the lowest number is on the left, the biggest number is on the right, so I have to use less than because I got to be pointing at the smaller number. I have to, so whatever your smallest number is, if your smallest number is here, your less than sign's got to point there. Now, for some reason, you flipped it around and put this put this biggest number or smallest number here, then you'd flip your signs and that'd be okay. All right, one more. Let's do some more dots. Okay, this one here. I'm going to put little dots on the x. Everywhere I see an x, I'm going to put a little dot. And there I go. I got 4 of them. And then for the y, I'm going to put bigger dots, just so I can kind of keep track of them. There we go. Okay, so let's write these down. Again, since I have dots, that's discrete, and discrete means a list. So I have dots at -3, -2, -1, and +1. So that's my domain. Those are my x values. For my range, I have dots at -2, -1, 2, 3, 4. Now notice, I don't have the same number of x's as y's, but that doesn't matter because these are the x values I have and these are the y values I have. I don't have to have the same number of x's and y's. Notice also, like right here, I had 2 of the same x value, but I didn't repeat it. I never repeat. In algebra, I don't repeat myself. I don't say things twice. Okay, so I don't repeat myself. Domain and range, I never repeat myself. Same thing with functions. When I'm writing a function and putting it into those bubbles, I don't repeat myself. Okay? So here is an example. This is also an opportunity. I'm going to do this one, since I did this one with the highlighter, I'm going to do this one with smooshing, just to show you what it would look like. So for this one, when I'm looking at my domain, I'm going to smoosh that arrowhead onto the x-axis. I'm going to smoosh this one onto the x-axis. And since they're connected, even though it takes a turn here, they're connected all the way through, so I'm going to connect them all the way through. That means all of the x values I have here, my domain, is all real numbers. Remember that funny R is all real numbers. Just pretend that is crazy looking. Okay, let's rewrite that. All real numbers. Okay. Now, when I look at my range, do I have an arrow here? No, I don't. So if I don't see a circle, I put a dot. So if they don't give me a circle here, I have to assume that I can include that value and put a dot. Now, I see an arrowhead here, but this one's higher, so I'm going to use that one. And they're connected all the way through. Well, look at that. This one, I have an arrow on one end, but not on the other. So that means I'm looking at an inequality. My y value that I have is -2. Are these values bigger or smaller? Well, they're bigger, and since it's a dot, I have to include those values as well. All right, that's all.